data, ways that you can clean and prepare your data. So first, let's think about what types of attributes you might have for all of your nodes. If you have an attribute data set, you would input it same way you would the social data, but it's going to just go into a matrix slightly differently. So for CampNet, we have the Camp ATTR data set. So for every single one of the nodes, I recommend copying and pasting into that first column all of your names of every single one of your nodes. And then you can list their gender numerically. So we have ones for females and twos for males. And then there's their role, and betweenness is used here as another attribute, but it's not typically what you would call an attribute of a node, but it can be used as one. If you only have attribute data for some of your nodes, you might want to match your data sets. So this would be one way of cleaning up your data set. So you would go to Match Datasets under Data and match one mode data with its attribute data. And you can input clicking this dot 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 and typing in CampNet, and you can match this to its data set, Camp ATTR. And it's not the case that any data is missing here, but if we wanted to only use nodes that were found in the network data set or nodes only found in the attribute data set, we can create a new file that's called campnet-matched and campattr-matched, depending on whatever the rule is for how we want to match the nodes. And that would give us an opportunity to just use that data that we have that both of those pieces of information for. There's some other ways that you, depending on the type of data you have, that you might clean the data or prepare it in other ways. If you have a two-mode data set, for example, I'm going to open up the Davis data set. And this is a two-mode data set where one mode are women and the other mode are events that these women attended. So E1 being event 1, E2 being event 2, and so on. So we might not be interested in displaying this as a two-mode data set. There's fewer ways that we can analyze two-mode data sets, so you might want to convert it into a one-mode data set wherein you look at how many times one of these women co-attended events with other women. So maybe they have a stronger relationship dependent on the number of events they co-attended, or if there was, say, a disease that occurred that one woman had, and if you were in contact with her less than 3 times you were okay, but more than 3 times you wanted to contact all the other women that they co-attended with, then that would give you a certain reason why you might want to put some data like this together. So to transfer that, we are going to first, I'm going to bring this up a little higher so you can see. I'm going to Data, and then Affiliations 2 mode to 1 mode. And I can input the Davis dataset here. And then my output dataset is going to be called Davis-rows. I could also say that it was Davis women if I'm using the rows. If I'm using columns, that would actually be the events. So that would be events that were connected because of the number of women that co-attended them. So that would be a slightly different data set. We're usually more interested in the people than the events. And so when I click OK, I see the new data set, which shows me each one of the women. So I have now an 18 by 18 matrix, and it's showing me how many times each one of these women co-attended an event with another one of the women. I can then recode that data if I'm interested in making it more categorical. So to do that, I would go to Transform and then Recode. And it's already loaded this for me because I was just working with that data set. But if I wanted to load a different data set, I would click the dot 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 here. I can select particular rows that I want to recode by clicking on this L, and then I can select just certain women that I wanted to recode. I won't be doing that here. Or if it was an attribute data set, for example, in that camp ATTR data set, the third attribute was continuous. I might decide that I just want to relabel that third column, and it's going to create an output data set, and you might want to rename that as, I might want to say that it's recoded. I might want to relabel it in some other way, or I could leave it the way it is. And then you'll see that there's two tabs. There's files and recode. If I click on recode, I can set up that recoding schedule. So I might say that values from 0 to 3 are 0 if this is the case that there's an infection and you need to be in contact with at least 3 events in order to contract it. I might say that I'm not interested in relations lower than 3, but that from 4 to 5 are a level 1 alert, and I would add that to the recoding, and that from 6 to 10 are a level 2 alert. And I can add that to the schedule. And when I click OK, it would recode all of the values in that matrix to reflect the what I just put into the schedule here. There's a few other ways that you can get a sense of what your data looks like before you start manipulating it or preparing it. One way is by running some univariate statistics. So if I go to Network or Tools and then Univariate Statistics or Control U, you can input the CampNet dataset, and it's going to create an output dataset called campnet.uni, and it's going to look at the dimensions in terms of the rows. So it's going to tell me the number of observations and the amount of missing data for each one of these nodes, which is really useful. And it's looking across the rows. The minimum value here was 0. That would be no relationship. The maximum was a 1, which is to be expected because this was coded as 0s and 1s for presence or absence of a tie. We also see that the sum of each row is 3, which is also to be anticipated considering each one of these people was asked to list 3 people that they were in contact with. And it gives me the average value for each of those rows, standard deviation, and variance. This just might give you a little bit of information to get you started as you look for things that need to be recoded or missing data that you need to address. You can also do a few other things to manipulate your data. So you might just be interested in only looking at major components in your network. So you can go to Data, Filter, Extract, and you can extract a main component, so the largest, densest part of your network. You could extract the ego networks for every node in your network. It would extract that as the ego and all the connecting alters. You might just be interested in a subgraph based on a particular attribute or some other submatrices, which we'll talk about later on. You can also unpack a dataset that has multiple relations to turn it into several individual datasets, or you might want to join either rows, columns, or matrices together if that makes sense for your dataset. You can transpose it without opening it up in the matrix editor by just going to Data Transpose here. And then there's some other ways that you can transform your data set. So you can dichotomize it. There's a more interactive method of that. It's more like recoding. You can symmetrize a data set here, or if you have transitivity rules that you're following. And you can take a look at this in your own time and decide if there's other ways that you'd like to recode or transform your data set depending on what might make sense. There's a number of things that you need to take into consideration before you do that, such as, what does it make sense to remove data? So if I were to go to data and then remove, I can remove isolates, so the unconnected nodes. If I I feel like those are truly not valuable to my network, that would make sense to remove them. But if I calculate density without them, I'm then sort of biasing my density if I say that they are not part of my network anymore. You can also remove pendants, which would be any node that only has one link. And again, if you remove that, it's just important that you explain why in your methodology. You're going to visualize your data in NetDraw. There's a lot of tools for visualizing your data, but right here within UCINET, you can click on this colorful icon and it's going to open up NetDraw. And I'm just going to need to resize this quickly for you. And so you'll see there's a lot of icons here, and the first one is just to start a new project. The second one is to open up your UCINET dataset. So I'm going to go ahead and click that file to open, and I'm going to open CampNet. And so it's going to size the picture to your screen. If you have a larger data set, you might need to go ahead and click the lightning bolt to get a better view of your picture. And so there's a few different layouts that you can use, and this is using a spring embedded graph layout. You can also create a circle display or play with a few other random styles of laying out your data set. This spring embedded layout is pretty useful for the most part, so I'm going to stick with that. And then you'll see there's a Relations and a Nodes tab. If I was interested in selecting particular nodes here, I could simply unclick nodes or add them back in this way. You can recolor all of your nodes. The most useful way to do this is by an attribute though. So let's go ahead and load up the attribute dataset. You'll see that the third folder over is an icon to open up an attribute dataset. So I'm going to open up Camp ATTR. And click OK. And now it will have opened up that attribute dataset. So I can select here that rather than seeing the node ID, that I'd like to see the node gender. And I can, with a click, just display males or females. And so that might be a useful time to use the lightning bolt to reorder that. You can add them back and hit the lightning bolt again. I might be interested in just people with a certain role, and so I can remove most of the network by just clicking on that. Or I might want to recolor by a particular attribute. So if I want to say that it's by gender, I would be making females pink and the males gray. And when I click the checkbox there, I've recolored those nodes. You can also change the shape of the node to reflect the role. So I'll have a circle for role 1 and a square for role 2. And I can toggle whether or not I'd like to see the actual names. If you have a larger data set, it might blur things, and that's just by clicking that L. We can also increase the node label size or the size of the shapes quickly and easily here. You can remove isolates or pendants. This is usually better to do when you're visualizing than actually manipulating your data set. You can just do it right here. You can also change the symbols, labels, and the outline of each one of these, or even your background color by going to Properties. Another popular thing to do is to size the nodes by centrality of each node, or the degree of centrality. So to do that, I would click on Analysis and click Centrality Measures, and then I'm going to set the node size by degree and click OK, and it will size each one of the nodes by its degree of centrality. If you're interested in what the degree of centrality is, you can click Nodes, and now all of the calculations will be set there, and we have a degree of centrality of 3, 4, or 5. You could remove nodes that have larger degrees of centrality, or only display the most central nodes and how they're related to one or linked to one another. If you're interested in saving the diagram that you made, you would go to File and Save Data Diagram As, and you have a few options. If you were really interested in the data set that you just created or wanted to use this as a way to winnow down your data, you can also save it as a UCINET data file after that. In NetDraw, we're going to now look at how you can do some basic measures within UCINET. So the first one I'll talk you through is just hybrid reciprocity. So you would use this if you have a directed data set and you want to see the amount of ties that are reciprocated within a network. So to calculate this, I'm going to go to Network, Cohesion, and Reciprocity. And I'm going to type in the CampNet dataset. And then you can create some partitions if you are interested. I'm not interested in doing that. And so this is a directed data set in that just because if Holly lists Brazy, Brazy doesn't have to list Holly back. But we can see the degree to which each person has symmetric or non-symmetric ties. And we can also see the overall hybrid reciprocity within the network. So we might be interested, if we have a directed network, to just start out by describing it by saying how many people have a symmetric relationship with others. The next thing, just as we did in the NetDraw tool, is to look at centrality. So we'll go to Tools, Centrality and Power, and we'll go to Multiple Measures. You can also just look at degree if that's what you're interested in. So I'm going to type in CampNet again, and it's going to create an additional data set called CampNet-Cent, and I'm going to let it auto-detect whether or not it's central, and I can select what measures of centrality I'm interested in. If you have a very large data set, you might just look at a couple measures of centrality because it'll take longer to load. And so because this is a directed data set, it's showing me both in and out degree, and I have many other measures of centrality here, and I can scroll all the way over to see all of those. Like I mentioned before, you can also use the Excel spreadsheet editor to open that data set. And so if I open it here, I'll have an easier way of copy and pasting my variables, or to click on a particular row and then reorder it largest to smallest to see who has the highest or lowest values. Next, I'm going to show you density. So density of a binary network is simply the proportion of all possible ties that are actually present. For a valued network, density is defined by the sum of the number of ties divided by the number of all possible ties. So it's going to be a little bit lower in that way. To calculate that, I'm going to go to Network, Cohesion, and Density, and I can look at the density overall. So for CampNet, for all possible ties, about 17% of them have been completed. You can also look at density by groups. So I would go to Network, Cohesion, Density, and Density by Group. And here I can use a partition like the attribute dataset to look by gender what the density is for each group. So here it's showing me the row partition and who is within each row partition. And I will scroll down to show you the density of ties. So we see here that the upper quadrant is female by female and the lower quadrant is male by male. And so I can see that among females there is more of a density by group than by males. And this would be the number of females that have connections to males and males that have connections to females on the other diagonal. One last thing we can look at is the components. So if we go to Network, Regions, Components, and then we'll look at Simple Graphs. For the CampNet dataset, we can select the minimum size to save and the kinds of components that we're interested in, and click OK. And it's going to show you the number of components with 3 or more members in them. Because there's already a major component here, we don't really have any differentiation that's of very much interest.